And now I'm very excited to introduce our honored guest. This is Ariana Walker from the Fleet Science Center, and she's going to be sharing with us her presentation, Get Girls Excited About Engineering and STEAM. So without further ado, take it away, Ariana.
Thanks so much. Yeah, I'm very excited to talk to you guys about what I do and what I know about this subject. I'm getting my presentation up. Here we go. Perfect. So, get girls excited about engineering and STEAM. This says STEM. I do both. I do all of it really. I'll go into that in a moment. But yes, my name is Ariana Walker. I'm going to tell you more about that in a moment, more about myself. But first, an agenda. I like to let you know what I'm getting into in these 50 minutes that we have together. So first is going to be some of my experience teaching girls in STEM, um, more kind of tips and specifics about encouraging girls in STEM, teaching engineering, and that's kind of more general to anyone, and then kind of putting them together and saying, how can we do both teaching engineering and kind of tying it in with those tips that I talked about with specific to teaching girls. Then I have some just kind of nice stories that I like to tell about the impact of my work. And as she said, I will have a Q&A session at the end, and I will be so happy to answer any questions at that time. If I see a really good question in the chat, I might even answer it earlier, but I can't promise that. So keep them in your head, okay? Or type them in, either way. All right, so myself. Hi, my name is Ariana. I have a BA in anthropology from UCSD. I also have a minor in psych. So I love people. I love to study people. I love to think about people. I love to work with people, etc. I've worked at the fleet for well over 6 years at this point. I've worked in pretty much all of the front-facing parts of it. So mostly the galleries, the classrooms, both on site and going to schools and teaching at different classrooms, as well as performing and writing our live science shows that we had for a while that are still going at schools as assemblies. Obviously not during this past year, but we were going pretty strong up until March of last year, and they will come back. I am sure of it. I also have been teaching very specifically a program called SciTech for over the past 2 years, including half of this year. So I'm going to be mostly talking about that because SciTech is a girls only program for 4th through 6th grade girls. It is after school. We generally do 5 to 6 schools, which with each meeting 1 day a week all throughout the year. We try to keep the same girls in for the entire year, see their growth, really teach them as much as we can over an entire school year. So I have some pictures to show you. These are some of my girls from actually a couple years ago, mostly. They were doing various types of science. We do almost every kind of science we can with them. So mostly here's some chemistry, whereas here they get to look through microscopes, which is always a hoot for them. They always just think that is such the epitome of doing science is looking through a microscope. We also do electricity, and here's another chemistry, but tied into teaching forensics, which they had a really, really good time with. Here is also, we always try to bring in role models, actual scientists who work in the field to speak to them at least once, usually 2, maybe even 3 times a year. So this again is a couple of years ago when we were in person. Yes, there I am. And they always get to talk to them. We actually just did that virtually. We're doing Zoom right now for SciTech. And we just had guest scientists join us in Zoom this past couple weeks. So that has been really awesome to still give them that experience of meeting real scientists and getting to ask them questions and hear their stories about how they got there. But we're still going strong. We use a couple different platforms to communicate with them and let them share the science that they do with us. So that's been awesome. So how can we use my knowledge to then help you guys learn how to encourage girls in STEM? One thing is obviously show them proper role models. So if you are a female scientist, boom, you're a role model. Awesome. If you're not, you can still be a role model. You can still encourage them and show them people who can be more specific to what they might be interested in, role models who might show them a specific path that they might be interested in, or a specific science, or again, engineering. However, what I've learned is that I did show them a number of different potential role models, and I told them their stories, and I said this woman was amazing because she did this science and learned this thing and discovered something or went to space, etc. And I also showed them girls around their age, closer to their age. And I said, who do you like best? Do you like all of these women who, some of them even look like you? A lot of my girls, because the schools that I go to are low income, a lot of them are people of color. And so I show them some perhaps white women scientists, and I also show them people of color women scientists. And then I, like I said, show them some of the younger ones. Guess who they like best? They like seeing the younger role models. And I think it's because it shows that they can do the science now. It's a guess, but nonetheless, this is what I've learned. At every single school, when I showed them this large variety of different role models, I said, look at how amazing these women are and look at how amazing these young women are. They always, always, always liked the younger women best. So I think that's a pretty cool takeaway from that. And it ties in to this that we say at the beginning of every session. This is what we call the SciTech Pledge. That's, again, my program is SciTech. And every single time we meet, someone leads us through this pledge. So I'm going to break it down really quick and tell you why I like this pledge so much and why all three of these steps are kind of important to me. The first step, the first paragraph, is pretty much a whole bunch of affirmations. So it says, as a SciTech girl, I try my best every day. I never give up. I speak my mind. I am creative. I am powerful. I am independent and I am confident. I am curious and I am brave. I am caring and I am helpful. It is positive things that they can feel about themselves and think that they are bringing to the group, to the world, etc. The second statement is just as important. So this is something that I definitely drive home, even if I'm not teaching this program, with any program that I teach. And I'll go into it a tiny bit more later as well. But it says, as a SciTech girl, I'm allowed to have bad days. I'm allowed to be confused by things and feel frustrated, and I'm allowed to make mistakes. So this is all about making mistakes and accepting that as part of the process. And especially with engineering, I always, always, always want to drive that home, that even adults, especially in engineering, will make mistakes, will struggle, will find things that will make them feel frustrated. And that is okay, especially that is part of the process. If you're making mistakes, you're doing it right. And so having this as part of the pledge, and I didn't write this pledge, this has been around for a few years before I was officially in charge of this program. So, but we keep it going because it is, I think, very powerful. So I hope that you guys like it as well. But there's one more statement, and this statement is just as important to me as well. So it says, as a SciTech girl, I am the best scientist, engineer, leader, and friend I can be. And so this ties into what I was talking about the younger role models that the girls liked. I feel that saying someday you can be a scientist, someday after many years of school, after a lot of study, a lot of hard work, you can be a scientist. I never liked that. I always, 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 and at the fleet, one of our kind of mottos almost is that everyone's a scientist. If you are observing things about the world around you, if you're questioning things, if you're making discoveries, you are a scientist right now. You don't have to wait until after you have a PhD, etc. You can be a scientist today. So I am the best scientist right now. And we say this every single time we meet, once a week, which means I say it every single day of the week, but it still makes me feel good every time. So some other things that girls respond well to. One is teamwork. So a lot of people think of girls, especially in my age group that I work with, 4th through 6th grade. Oh, that's rife with oh my goodness, aren't they so catty? Isn't there so much infighting? Aren't they always like, talking about each other's who knows what, right? But it's true and it's not true. That does happen at that age, but also those girls love to work together. They love to build on each other's skills, accomplish things as a group, make friendships that are very strong based on struggling with something difficult, as well as just accomplishing something real, making something that seems important to them. They also really respond well to stories. So if you can somehow create a project for them to do that also has a story for them to follow, they'll be a lot more engaged than if you just say, make this thing, make me a car, make me a house, build this thing. They will actually like it a lot better if it's make me a car because this person needs it really bad, and it needs to have this very specific like way that it has to move. Talking just out of nowhere, but I promise you that if you include a story, if you make it like a narrative, they will respond better to it than if you don't. And thirdly is helping people. So girls of that age are also extremely altruistic. If they think that they're going to be helping someone, especially kind of someone specific, someone they know, maybe, okay, make this car for your grandma. She needs to be able to get around more conveniently, more easily. Maybe it needs to be self-driving because she is getting older and maybe isn't safe on the road anymore. Whatever the reason is, make this for your teacher, for your doctor, for a scientist. They will really want to do that and really want to help that person. And then I've got that broken record up here. If you've gone to any other talks this whole Steam Power convention conference, I'm sure you've heard this, hands on. And this goes for girls or for any audience. If you can somehow have something hands on when you're trying to teach someone something about your science, or even just show them like what you do at all, they will learn so much more and take away so much more from it if there's something hands-on about it. It does not need to be goopy oobleck, I promise. So I don't even need to go over these. You've heard them, I'm sure you have, but I'm just putting it out there again because everything I do is hands-on, and they always, always, always respond way more to it, especially the less I talk, and I can talk a lot, as you could probably guess right now because you're hearing me. I could talk a lot. The less I talk and the more hands-on they do, the better they get from it. The better they respond to it, the better outcome. So how do we turn this into teaching engineering? So again, now I'm not going to talk as much about girls specifically. Let's think about just how do we kind of engage anyone in engineering or teach them engineering. This is the this is the definition that I always use. Engineers make things to solve problems and help people. So for one, this is accurate. For two, it's very simple because engineering is so complicated, right? Engineering is a lot of things, which I'm going to go into in a second too. There's a way to address that, but you can't go over all of it if you have people's attention for a very short period of time. So if you tell them something like this that just gives them the impression of what any engineer might be, that will help them kind of get the picture in a much shorter period of time. So I say solving problems. Obviously, they find problems in the world around them. They think, how can I actually fix this? How can I make this better? How can I make a better product? How can I do something that will fix this niche, get into this hole that is, in the world, and then helping people. And again, that ties into getting girls engaged, right? If you automatically say right there that you're going to help people, they're already going to be a little more interested. And then this slide I actually use. This is exactly also a slide that I pulled from a different PowerPoint from teaching the girls engineering recently. And I've used this slide for like 3 years. And it's just, again, it's showing that, okay, as much as that very simplistic definition kind of works for me, I also love showing them there's also not just one route. There's also not just one engineer. You're not only going to be, if you want to make bridges, awesome, go ahead. But that's not all that engineering is. Engineering is also environmental and energy types of engineering. engineering cars, engineering soundproof walls for a music studio, computer engineering, space, NASA engineers, etc., JPL. There are so many different facets, and we don't even go into nearly all of them on this, but it just shows the variety so that they get the idea, like there are so many different options if you're interested in engineering. And then quickly, some hands-on teaching tactics. So there's two main ways that I might do an engineering project. I might hand them materials and tell them, like, build me something. I might even say, build me a very, very tall building, no other rules, and say, good luck, here you go, and see what they come up with. And other times, obviously, we want to give them much more specific parameters, much more specific of a kind of a prompt. So I might say, we're going to build a robot that is going to doodle all over the table. And it kind of has to be a specific way. I'm going to help walk you through it. There are some decisions that you get to make, but for the most part, the model, the overall kind of shape that it has to take has to be kind of similar to something that I'm going to tell you. And then you can make small tweaks here and there of kind of weight distribution and that is where you're going to learn the engineering skills. Both of these are good. Both of them have worked for me many times. You just have to think, if you're going to be doing a hands-on project, especially engineering, you have to kind of think, how many instructions do I want to give? Do I want to give very, very limited amount of instructions, or do I want to give a lot, or somewhere in between? Thought it'd be helpful to tell you that. And then limitations. So in real engineering, there are many constraints and limitations that engineers have to follow. These are two just super simple examples, of course, but we have time, right? They're always limited on time. They're always limited on budget. They also might have material limitations. They might have personnel limitations, but I go into these with my students oftentimes. So not necessarily every time I teach engineering, but definitely as often as I can. I say, okay, what are the limits here? How are we getting limited? Can we use any material we want? Am I giving you a week to do this, or am I giving you a 2-hour period? Like, you have just a very short limited amount of time. And asking them if they think that real engineers also have those kinds of constraints. And then I also often teach them the engineering design process, which again, many of you may have seen before, but if you haven't, welcome. I like this graphic. There's only one word that I always say different, which is I use the word test instead of experiment. It's the same. Ask, imagine, plan, create, test, improve. I talk about the fact that it's a reiterate process, that it's not just 1, 2, 3, 4, 5, 6, you're done, and that it goes round and round, slash sometimes backwards, slash sometimes skipping steps around. I also talk about the fact that sometimes I absolutely lead them through these steps. I might not even give them their materials at first, and I might say, okay, sit with your team, define your problem, 2 minutes. Okay, now take a piece of paper, start imagining possibilities of what you could do to solve the problem. 2 minutes again. And very, very specifically lead them through each step. Other times I teach them this and then I just let them go anyway. And I say at the end, like, who followed these steps? Did any of you actually sit down and plan it a little bit first before you started building? Or did you jump in and just start playing with the materials and try to build something without thinking it through ahead of time? Again, both processes lead to good results. But again, I thought I'd tell you about my different options there. So now we're going to take all those different things and kind of put them together. So how can we now tie in those things that I use for any audience to teach them engineering, and those things that I've learned about how to help engage girls and kind of bridge the gap there. So we're going to look for teamwork, a story, helping people, a hands-on element, limits that I put on them, the design process, maybe, right? So this is a project that I've given them at least once or twice, and it is literally to design a chair that has to actually support weight. One of their teammates had to actually be able to sit on, and they would only be able to use paper and tape, and a specific amount. I gave them 22 sheets of paper, I'm pretty sure, and a tape length of my arm length, which is like about 4.5 feet, because I'm about 5 and a little bit feet. So it's about that long. And that was it. And I said, okay, I'm not going to tell you anything else. Here's some pictures of chairs that you might recognize, but I tried not to give any that were too useful in the structure, and then let them go at it. So this has, a limit, obviously, of the materials, and as well a time limit. It has a very specific goal and constraint of trying to build something that actually has to take someone's weight. And they have to think outside the box, especially about the materials, right? They get a flat piece of paper and they have to get to the point of rolling it like this on their own. I do let them share ideas. So I say, hey, like, you're struggling really hard with this. You're having trouble figuring out, like, you're trying to put the piece of paper like this or fold it in a different way. Look at what they're doing. Like, does that seem to be working well for them, that they're rolling the paper? What if you try that? So I also try to ask them questions to try to get them there on their own. But generally, these two actually worked. They were the two strongest designs. They supported the weight the best. And so they're pretty awesome. This project was a little more open-ended. So I gave them something they're very, very familiar with, playgrounds. And I said, you know what playgrounds are, you know what they're supposed to look like. So design a playground, use just the recyclable containers and materials that I gave them, and do a model of a playground. And you can invent it, like, it has to be a real thing that someone could actually use if it were full scale, or it could be kind of a mythical, magical one that might not actually work on Earth. That's fine. And they came up with all sorts of amazing things. This one on the left, obviously, it has like a little swing and also the thing to climb. And, like, I don't know even if that other thing is supposed to be like something bouncy. And then the one on the right has a slide and a upper area, and I'm pretty sure I remembered they put little like pipe cleaner pieces in the top, and they said that the top part was a ball pit. So they definitely think outside of the box, and especially when it's something they know that well, like a playground. Like, of course they're very familiar with that, so they think, what would I want in a playground if I were making a playground that I wanted to play in? Like, what would I include? What would be really fun to play in? I also forgot to mention that for this one, I said it had to be for just children at their school. So again, it's giving them someone specific that they're helping. So I said, any of the children that go to your school, if you were building a new playground for your school, what would you put in it? And then I get even more broad. So I can't take full credit for this one. This was actually given to us by an awesome organization, the Science Museum in Ohio called OMSI. And there are 4 categories. We usually use only 3, and it's a design challenge based on a random assortment of options that they might get that will fulfill these different categories. So design, and then there's a specific object they'll get 4, and then there's a specific person they'll get to use in, and then there's some kind of crazy scenario that that person's in, and then sometimes there's an extra constraint, and those one more things might be make it useful twice, or make it something that can be more easily portable, or make it more efficient, whatever it might be. So I have pictures of those cards as well. So there's a bunch of different potential objects, and they're literally cards that I have. They're at the museum right now, but you literally just hold them up like a deck of cards and pull one out. And we even did this digitally, and it was awesome. I usually in person would have them obviously in teams, and then give each team one set of their own group of the 3 different categories. This time I just did 2 each and then let them choose. But yeah, it's things like make a music player, or make something for first aid, or make something to wear, or a light source. A bunch of different options. A bunch of different options as well for what we call the user, who's going to be using or needing this object, right? So it can be more general, like a child or the elderly. It can be a doctor or a police person, or a wheelchair user, or a fairy. So this one does get a little sillier with a couple of those options, as you see. And then again, the situation that they're in. So they might be in a hurricane, or very notably the plague. They might be facing a robot or alien attack. or again, some that they're more familiar with, like an earthquake or a flood. And so these are a lot of fun because, again, they do tell the story automatically. So when you're not sure necessarily what to give them as a kind of a story and a person to help and what to make, boom, they're all there for you. It just is given to you automatically. So that's definitely been nice. And again, it's very open ended. So with these, I do definitely give them a lot of freedom into what they might create in this very specific and sometimes very, very random scenario. And then for my program, SciTech, we would normally be ending the year in what's called Tech Challenge. It's a giant competition that involves all of the schools. So at each school, we break them up into teams a few weeks before the actual competition. They go through the whole process. I have a bunch of pictures of that, so I'll show you that in a second. And they have a very specific big challenge to try to accomplish. So 2 years ago, this one was a drop and deliver device. So they had to build something that would withstand the drop of a 10-foot from a 10-foot height. And then hopefully, and there were various levels of success on the movement part at the bottom, but the winning teams did actually make something that could actually move once it landed. The goal was, of course, to make it so that it would move kind of a specific distance. We kind of gave up on that, seeing their level, but they were definitely able to make things that landed and like landed very safely. And then some of them moved a little bit, and those were the ones that did the best. So they were broken up into their teams. At the near end, we had a preliminary competition where they actually competed between the teams at their school. And then that next weekend, we had the big competition where the winning teams from each school competed against each other. So I have some pictures of this. We didn't actually get to do it last year because of COVID times, and we probably won't be able to do it this year either, which is a little bit sad, but it should be back hopefully next year. So they get to do all of their own building. I do take them through the engineering process. So I do make them sit down and like talk as a team first. They get to use hot glue guns, which they're very excited about, and X-Acto knives. And I'm very, very strict with them on being extremely careful and safe with those, but they love doing it. They get very excited about using those kinds of extra kind of tools. They then test them on their own. So these two are actually kind of testing. They made this door to kind of pop open, like it kind of holds itself up. They put little tiny, you can't quite see them, but little tiny pieces of cardboard in the sides to kind of hold it up in place while it drops. And then the impact would open the door. So they're kind of testing the actual door opening in their little car on the inside. And this one is dropping her one from the short height just to see how it fares, even from just that few feet, to think how it would fare from 10 feet. Then they test on the big rig. So this one, my supervisor at the time, Jason Mazarek, who might be here, actually made this. And literally it was a rope, kind of a big, strong twine that we could pull down, attach to their device. And then one teammate would pull it all the way back up, and there was a hook that would hit a thing and let it go. So it would drop it down from fully 10 feet. So they got to test it all before and then also have the preliminaries. I think both of these were the week before when I just brought the rig for them to just test. And then this one is the preliminaries. So they're actually trying it and hoping to win at their school to be the competing team. And then the competition. So here's just some details. When they walked in, their devices were all on display. From each school, it was the winning device that would be competing, and also the second place device, just so that it could be on display for people to look at. We put this awesome banner on top of the drop rig, which I just thought it was neat. And then this printout of Mars, because the idea is we are creating a drop and deliver to go to another planet. And the awesome example, especially now, though this was 2 years ago, before Perseverance was even like quite close enough to land, but now it's there. But thinking about dropping and delivering supplies to Mars. So we have it literally pictured, which I thought was neat. And then I made these trophies, which are Mars and the cute little Curiosity rover on top. And so that's the whole picture there. We had 3 guest judges who were actual scientists who we called in to make sure that they were third party, like not influenced by knowing the girls or anything. And then we have the picture of my winners. So these are my girls. They're the ones who won. If they won second place, oh, well, it was first, second, and third place. If they won fourth and fifth place, the 2 other schools, they still got the rover, which was pretty cool. But yeah, it was big day. Ooh, there's something. So SciTech's impact. So I have just a little more time. Perfect. This is working out okay. So I have a couple stories to tell about kind of my program's impact, like I say, or what I learned from how well it went over, as it were. So I did a whole week or unit. It's 2 years ago. I should remember this. Or was this last year? Oh, COVID has been a time. So we did a whole unit on sustainability either way. And one of the activities I did was having them do a scavenger hunt around their school, which they loved. They loved being able to just run around their campus without like having the constraint of like having to be in line in a class or having to try to get to class on time, whatever it was. I just put them in teams, gave them this sheet and said, go look for these things. Do not leave campus, but run around, be free. I will walk around and make sure you're safe. And also, like, we'll come back at this time and check who has the most amount of things. And during that time, I also had custodians from their school and other representatives who would know about this kind of thing come and talk to them about pretty much anything that they wanted to know, but mostly I was thinking focusing on waste management at their schools because that's related to sustainability, thinking about teaching them like, hey, let's not just talk about people recycling or throwing trash as litter in the beach somewhere else, like wherever that you don't necessarily need to think about, like somewhere that's just a place and then it's somewhere kind of fictional in their head. Let's talk about your school. Let me talk to you specifically about the place where you spend a lot of your time. So bringing in those representatives was very helpful and they had a lot of great questions for them. In that time though, one of the schools, after the custodian talked, some of the girls said, oh my goodness, I feel like we take him for granted. I feel like we don't thank him very often. And, like all the students, I feel like I never see people thanking him. And like, he does so much for us. And like, we're so bad at throwing away our trash in the right place. Like, and he picks it up after us anyway and still loves us and cares. So they said, how about we write him a thank you note? They ended up all signing it at the bottom. Maybe I shouldn't be showing it with their names. I did not even think of that. Sorry. But nonetheless, they did end up all signing it. I took it when it was just these few so far. But yeah, it says, we are sorry that we don't thank you enough, but we really appreciate that you help keep our school and environment. I think they forgot to write clean or safe. We are lucky to have you as our janitor. So it was super duper sweet of them to do this in relation to having, like I said, their custodian come speak for them. So I thought that was awesome. And then at a different school, this happened. The principal actually would talk to us and say, so when I used to walk around at the beginning of the school year before SciTech started, because it starts like a month or two after school starts, I would hear these conversations at lunch and it would always from that level, that age group of girls, they're always talking about certain things and it's always, my job is going to be working at Target or a grocery store. I'm gonna be a mom and have children, eventually. Like these kinds of talks, this kind of future planning that's thinking about the careers that they're kind of more familiar with and or aware of, thinking about what they're aware girls turn into, which is moms, etc. And not necessarily other things about their future when they're talking about that specifically. And he said that later, after SciTech had been around for a couple months, he would walk around and hear them talking instead about the science we were doing, about cool science careers that they learned about just the projects that we were creating in class instead. So that was like, when he told me, I was like, wow, that's super powerful. I'm actually making an impact. There's something real coming from this. And it was very, very moving to me, at least. So I thought I'd share that. And then I have a couple quotes, but I think I'd get to questions soon. So just nice things that the teachers and principals said from last year. Since we had to cut it short, we usually get like a full questionnaire, a full survey from them at the end of the year. But because we didn't quite finish last year's school year of SciTech, we kind of asked them for just a couple quotes instead. Um, and it just says they start to love science, become very exposed to different fields in science, get the opportunity for many hands-on activities and experiments. They're empowered to think outside the box, gain strength in collaborating with others, persevering and following through in projects. These were very fun to read when I was kind of sad that the school year got cut off, and then at least I saw that there was some kind of good thing coming from it still.